Okay, so let's look at this problem. How many integers are there from 1000 through 9999, right? So what you can think of is you can think about into two ways. So number one, since these are the consecutive integers, so you can think about it's doing accounting things. So starting from 1000 to 9999, so how many integers from them? Which is going to be 9999 minus 1000 plus 1, right? So that will give you, it's now 1000, okay? Or you can think of as a using the multiplication rule, in counting. So think about those are the 4 digits that you can fill in. So for the first digit here, how many choices you can have? You're going to have 9 of them because you can only choose any number from 1 to 9. You cannot select the 0. Okay. But for the second digit, third digit, and the fourth digit, you're going to also have 10 choices, which is 0 to 9, right? So if you multiply them together, that will also give you it's 9,000. Okay, so that's the part 1. Now part 2, it said that how many odd integers are there from 1000 through 999. So this problem, again, we can use in this multiplication rule still to think about this. To make my integer to be an odd integer, noticing that I just need to put one restriction for my last digit, right? So as long as this digit, it's going to be 1, 3, 5, 7, and 9. So I'm all good. So in other words, there are 5 choices for my last digit. And then for the first 3, this is exactly the same. So it's 9 times 10 times 10 times 5. And if you do the calculation, which is 4,500, okay? Which apparently, as you can see, which is half of the integers, right? That's, yeah. So number 3, so how many integers from 1000 through this has a distinct digits, okay? So talking about the distinct digits, it's in other words, 1, 2, 3, 4, this is good, okay? But you cannot have 1, 2, 2, 4, okay? So this is not good, okay? So still, we can borrow this idea, right? So if I select one of them here, and then noticing that for my second digits, I'm going to have 10 minus 1 selection because here I cannot repeat with this one. Okay, so it's going to be 10 minus 1. Okay, and then for my third digit here, since the first 2 digits are already selected, I'm going to have 10 minus 2, right? And then similarly, for the last one, I'm going to have 10 minus 3. So in other words, this is 9 times 9 times 8 times 7. Okay, so I mean, you can finish the calculation here. I don't want to do that. Calculator can handle that. So number 4, so how many odd integers from 1000 through 9999 have distinct digits, right? So again, how do we think about this problem here? Well, very similar to part 3, but you need to combine it with part 3 and part 2. First of all, you see, it asks us, we need to make sure that it is odd integers, right? So, in other words, we need to select the last digit first, which is 5 options, okay? And then when you select one of them here, you see for your first digit, you're going to have 8 choices, right? Because there's one of them you already selected here, right? So for the second digit here, you're going to have 8 selections. Why? Because before, if it's no restriction, you're gonna have 10 ways to select, right? 0, 1, 2, 3, up to 9. So that's 10 choices. But you already selected 1 for your last digit, so you get rid of 1. And then you also select another one from your first digit, so get another one. And then similarly, you're gonna have 7 options here, so that are gonna give you yeah, so it's 8 times 8 times 7 times 5. Okay, so, and then lastly, what is the probability that a randomly chosen 4 digits integer has distinct digits? Well, so basically you're going to use the result from part 3, right? And then over the result of the first part. So number 5 is using the result of 3 over the result of 1. Okay, so this is a problem. So hope you enjoy this. Thanks.